Hi, I'm John Stapleton with CodeVA, and this is a tutorial on using if statements with the material computer. A material computer is, of course, a imaginary computer that we execute code on using objects, manipulatives, and this sheet of paper here. And I'm going to talk about if statements today. So what an if statement is a line of code that tells the computer to make a decision about running or not running a sequence of code. So I'm just going to make an example here. If I create a Boolean variable, or if I tell the computer to create a Boolean variable called a, I'm going to put a value of true in there, then I can use an if statement and have the computer do something. Now, there are lots of ways to write if statements. This is using some a pseudocode language, and to read this program and execute it using the material computer, we of course will start with the first line. We're going to create a variable called a, and we need to put a value of true in that variable called a. So I'm going to grab a little slip of paper here. We'll write true on there and throw that into the variable. All right, a now has a value of true. Next, I need to read and interpret this if statement, this line here that says if. Now, the way this if statement works is the computer is going to look at the value of this variable. If the value of this variable is true, it will execute the lines of code between if and an if. If this value is false, the computer will actually skip all of this code and jump down to this area. And I'm just going to add another print statement here so we can demonstrate that. So I'm going to run the code in this configuration right now. We've already done line 1. We have the value of true in the Boolean variable a. Let me grab my output console here. There we go. Okay. I got my Boolean variable a. And now I need to have the computer look into this variable and see if the value is true or false. We've just assigned this, so it's not that hard, but it is true. So the computer should execute this line that's between the if and the end if. So in this version of the program, the computer will print yes. And then after we run out of instructions in the if statement, we will continue past the end if to the next line. All done. Great. Now, the way that this program runs is different if the variable a has a value of false. So let's reset everything. I'm going to cross this out and start over again. This time, we have to give the a variable a value of false. So I'll make a little false card here. False. Throw that in there. Great. Now for this next line, just like before, the computer is going to look inside the variable and see if it is a value of true or false. Now we just put it in there so we know it is false, meaning that because the computer saw a value of false in this variable, the computer will skip this line. In fact, it will skip all the way past end if and then do the next line. So in this version of the program, all the computer does is output the phrase all done. So that's if statements. This process is called selection. The computer is selecting which lines to execute from the program. Now, there's a couple ways to make this a little bit more interesting, because just having the computer run false or true based on a false or true statement isn't all that interesting. What if instead we had the computer compare two numbers? The way we can do this is by using what's called a Boolean operator, or a relational operator. So this was a relational operator less than. And if I take a value of 3 and compare it to the value 1, you can evaluate this expression as either being true or false. So when you use a relational operator, the computer compares two numbers and then outputs a Boolean value. Is 3 less than 1? Well, no, it's not. 3 is not less than 1. So this operation would result in a false value. But if I were to flip this around and instead compare 3 to 2, is 2 less than 3? Indeed it is. This means that the computer would resolve that expression to a value of true. So we're kind of like adding another layer of complexity here. So in my current program, we're checking if 3 is less than 1. And then we're going to take the result of that and store it in the variable called a. 3 is not less than 1. So we get a value of false in the variable, and we'll clear all this off. Now we can move on to the next line and evaluate the if statement. A is false, so we skip the block of code inside the if statement, and we get to print all done. Same as last time. Now, one final wrinkle. This is still deterministic behavior. Oh, and just to note here, I could also use a variable here if I wanted to. If I wanted to have a variable like b equal to 5, I could do that, or I could have b over here. If I had another variable, oh sorry, yeah, I'll just use that. That's fine. I could do it like that. Like you can write relational expressions just like you write arithmetic expressions. They can include variables, or they can not include variables. It's kind of up to you. Now, to make this a little bit more interesting, let's use a random value here. So now, instead of comparing two numbers together, we're going to have the computer choose a random number, and then we're going to compare that random number to 3. And based on the results of that expression, the computer will either execute this line of code or skip this line of code. So let's get everything ready to go. I'm going to create a Boolean variable a, and the value that goes into a is going to be the result of an expression. Random is less than 3. So let's get 3 out there. A quantity of 3, integer 3. And then I need to do a random value. So I have my 6-sided die. I'll roll that. And I got a value of 5 for that. So is 5 less than 3? No, it is not. So the result of this expression is false. False goes into a. And we throw a down here, and then we continue. Now, because we've done this a couple of times, you probably know by now that because a is false, we're going to the computer, not we, the computer will skip this line of code and jump straight down to all done. So this is the version where we skip the line. Now, if I roll a different value, let's say I roll, that's 4, still same. 4, still the same. 5, oh my gosh, we're rolling great. There we go. So if I roll a 1, now this statement is true. So I can put a true value in my variable. And then when the computer goes and checks it as part of the if statement, it will get a different value. In this version, the computer will print yes because A is true because I randomly got 1 on my dice instead of 4 or 5. So this is an example of what we call non-deterministic behavior. Because our if statement depends on a random value, we don't actually know what the results of this program will be. We have to have the computer execute it to figure it out. So that's how if statements work. Now, there's a couple of like nice things to make this a little bit more succinct. So we don't actually need a variable here. We could just put our relational expression in the parentheses like that. That's a little bit more common. We also could add as many lines of code to this block as we would want to, and the computer will check the expression and either run all of these lines or skip all of these lines and go straight down to the next thing. So you can kind of write longer blocks of instructions that fit inside those if statements. So that is how you read and trace if statements with a material computer. Good luck and happy coding.